Hello, welcome to Math 111 class. I'm excited to be here today. Our topic today is elementary set theory. And this can be found in Module 1, Unit 1 on page 8 of your course material. Do you know that the Earth is spherical in shape? Yes. And we can liken the whole ball of the Earth to be a set, a very large set. And let's call it E. That's E for Earth. Do you know that you and I and all the other people here on Earth are all elements in the set E? In fact, we could further subdivide the elements in the Earth into different continents, and then to regions, and then countries, and then states, and to different local governments, and communities, and streets, and houses, and people. Yes, the Earth is an example of a set, and in everyday life, we often group certain things together. For example, we speak of a fleet of cars, a football team, the countries in Africa, a set of dishes, and so on. These are examples of what is called a set. In each of the above examples, there is an obvious connection between the object of the set and the elements in the set. For example, we may have a set consisting of the following objects: a table, a laptop, and a biro. It is important that, given any object, we should be able to tell without ambiguity whether or not the objects belong to a given set. Such sets is said to be well defined, and this is the kind of set that we shall discuss in this topic. Now, at the end of this topic, you should be able to define a set, you should be able to define a finite set, you should be able to identify a subset of a set, and then state a proper subset. Now, what is a set? A set is a collection of distinct, distinguishable objects. Each object of a set is called a member or an element of the set. We often use capital letters like capital letter A, capital letter B, or capital letter C to denote a set. Small letters to denote the elements of the set. A set may be described by one actually listing all the elements in the set. This is called the tabular form. Or stating a rule or properties which decide whether or not a given object is an element of the set. This is called the set builder form. Now, in the tabular form, the elements of a set are written down and separated by commas, okay, as you would see in your example, and enclosed in a curly bracket. Now, when the set builder form is used, we denote a typical element by the lowercase, followed by the colon, or a short vertical line, and then a description of the typical element. Let us consider some examples. Now, write the following sets in the tabular form or set builder form as appropriate. The set consisting of a lion, a tiger, and a chair. Now, the solution to that will just be that we define a set A, we call it capital letter A, and then the elements in that set A is the lion, the tiger, and chair. And we can read it as A is the set whose elements are lion, tiger, and chair. So what is a set? A set is a collection of distinct, distinguishable objects. Each object of the set is called a member or an element of the set. So we often use capital letters like A, B, or C, capital letters. And we use small letters to denote the elements of the set. A set may be described by actually listing all the elements in the set. This is called a tabular form. Or stating a rule or property to decide whether a given element is part of the set or not. This is called the set builder form. So in the tabular form, we just list the elements. For example, if we have a set A, the elements in A is given as maybe A, B, and C. Okay, so this is the tabular form. Okay. So in the tabular form, we always write the sets as this I have on the screen, and we always separate them with the commas, and then we enclose in the curly bracket. Now, when the set builder form is used, we denote a typical element by the lowercase, followed by the colon, as I would show you. Okay. So in the set builder form, we denote a typical element by a lowercase, followed by the colon, or a short vertical line and then a description of the typical element. Let us consider some examples. Write the following set in the tabular or set builder form as appropriate. Okay, so we have the set consisting of a lion, a tiger, and a chair. So to solve this in the solution, suppose we call the name of the set A. Okay. The question says that the set consists of the lion, the tiger, and a table. So we just write a lion, a tiger, and the table. Okay, those are the elements of that set. Okay, the next question says that a set consisting of all Nigerian mothers. Now, to solve this, the set consisting of all Nigerian mothers or all Nigerian women who are mothers, there must be millions and millions of them. So it will be therefore impractical to list the names of all such women. We therefore use the set builder form. Okay, so suppose we call the name of the set B, then we may write B as B is equal to X, such that X okay, all right. So each of these reads that B is a set, and having the elements X, such that X is a Nigerian mother. So the symbol dash, or sometimes we use the colon, we call it such that in mathematics. Okay, so X such that X is a Nigerian mom. Now we're moving on to a finite set. When is a set said to be finite? A set is said to be finite if we can list all its elements. In other words, a finite set consists of a specific number of elements. And then, of course, if it is not finite, then it is infinite. When a set is finite, it is sometimes convenient to introduce a notation for the number of elements contained in the set. The number is often called the cardinal number. Okay, so for instance, if we have a set A, we write a set. So for instance, if a set A, if A is a set, then we need to find the number of elements in A. We denote it as NA, and I would write as N A. Okay, so that's the number of elements in the set A. So for example, if we have a set A given as so 1, 2, 3, A, B, C. Okay, this is what we have in our set A. If we have this as elements in our set A, to know the cardinality of the set A, that's the NA, N of A, is going to be given as the number of elements in A, that's 1, 2, 3, 4, 5, 6. So the number of elements in the set A will be 6. And that is called the cardinality of the set A. Now, the symbol E, when we say the symbol E and not E, okay, is used to mean that when we use the symbol E, we mean it belongs to. Okay, so when I write X in A, the symbol E means in. Okay, so that means X is an element or is a member of the set A. Okay, and the symbol not E, the symbol this, okay, means that X is not a member of the set A. Now moving on to subsets. Consider a typical school. Any school is a collection of people, buildings, books, equipments, and so many other things you can find in a school building. Okay, so suppose we regard this collection as a set U. Then in a typical school, U will be given by for example, we have U to have the elements Mr. Mike, Miss Tina, Mrs. Gold, and Tokwe and Tola, classroom blocks, workshops, chalk, markers, books, pens. Okay, so this is a collection of people, buildings, books, and equipment. We may then wish to distinguish between the various members of this, like we say the collection of people, okay? If we call that set P, the collection of people in the school, or we say a collection of inanimate objects, okay? All the other things that can't talk in the school, let's say we call that a set I. Then we will then have two sets, say set P, which we denote as, so if we call set P, denoting people to include Taiwo, Tokwe, Ayo, okay, and so many other people, okay. And for the inanimate objects, if we call it the set I, okay, to contain things like the chalk, pencils, okay, pen, tissue, socks, and so many other things you could find in a school, okay. Now these sets have been obtained by removing some of the elements in the big set U, okay, and then taking some of the elements one at a time. A set is obtained, a set, okay, the kind of sets that we obtain this way are called subsets, okay. So notice that when we talked about the set U, we called U we said let U denote the school, okay, all the elements in the school, and then out of all the elements in the school, we've taken out the set of people, okay, that's Taiwo, Tope, Ayo, and all the girls and all the boys and all the teachers, okay, we call those set of people, that's a set in the big set U, and then we have the set I to denote the chalks, the pencils, all the inanimate objects in the school. Now you will find out that we have been able to successfully split the big set U into two sets, the set of people and the set of inanimate objects, okay. So those two sets that we've been able to separate from the big set U are called subsets, okay. So the set P and the set I is called a subset, okay. Now what is a proper subset? A proper subset is said to be a set who has, if we have a set A, when we call B a proper subset, if all the elements in A can be found in B, and we write it as, okay, so we write that A is a subset of B. If all the elements in A can be totally found in the set B, okay, if all the elements in A can be found in B, then we say A is a subset of B. Let's write all the subsets of read, eat, and sleep, okay. So if we remove all the elements of the given set, let's call that set A. Okay, so if we're to write all the elements in this set, read, eat, and sleep, then we have, if we're to write all the elements, then the first element we'll have, that will be the empty set, of course. It's either we take some or all of it or some of it, okay. So the first set we'll have will be the empty set, and then the next set we'll have is a set containing read, the next one containing eat, and then the next one containing sleep, okay. And then now we begin to take them in twos. We have read, eat, we have read and sleep. We also have eat, and okay. Now if we remove all the elements of a given set, or if we remove some of the elements, then the first thing we have, of course, is the empty set. Then we have read, we have eat, we have sleep, read, sleep, then read, eat, and sleep. Now these are all subsets of the given set, okay, B. All right, so what have we learned today so far? Okay, so you have learned that a set is a collection of distinct distinguishable objects. You have also learned that each object of a set is called the member or an element of a set, and then a set is also said to be finite if we can list all its elements, and if a set is not finite, then it is infinite. A set is also a subset of a set A is thought to be a subset of a set B if every element of A is also an element of B, and we can denote this by A being the subset of B. Okay, and we've come to the end of this topic. With all the definitions and explanations I've given, I expect that you should be able to attempt the self-assessment questions. You can check out some of the books in the further reading section for more explanations. You are to submit your TMA via my email address. Feel free to contact me via the website also. See you next time.